Hello, one and all, and welcome to today's session of our 21 Days of Python. And so, as always, let us go ahead and then see what is our outline for today. Today, we will be looking at errors. The general topic for today is exceptions and error handling. So, we're looking at errors and then exception handling. So what that particular term means, we will get to know very soon. So let me get quickly into PyCharm and explain all the things here with code. As always, I have my file created in advance at day15.py. Okay, so what is an exception? The term exception itself, what is it? We can say an exception is an event that disrupts the normal flow of a program's execution. So anything that disrupts the normal flow of your program's execution is called an exception. Let me see if I can get it in the slide. Sorry, I should have added that one earlier, but okay. So sorry about that. Okay, so an exception, as I said, is an event that disrupts the normal flow of your program's execution. So let's say you have intended your program that it performs a specific task, but something happens along the way, and then that is in the process of the code's execution, and then it's not able to do what you told it to do. In that case, we say an exception has occurred. Yes, that is the term. Maybe to you it doesn't really match up or it doesn't really explain it well, but that is the term they chose to give to it. Anything, so any bug, you can say so, or any wrong use of algorithms or data structures, that's, let's say you want to perform an addition or a multiplication or maybe a division, and then instead of dividing, you take the number from the user, you know that it comes as a string. And so if you want to do the division, you have to convert it to an integer before, and you forget, and you try to use the string for the division, an exception will be raised. So that string that is going for the division will disrupt the program's execution, and what is called an exception will be raised. So think of it like the program will break, and then Python will try to tell you what is wrong. So I think the code would explain it better. So exceptions usually occur when the interpreter encounters an error during the execution of a statement or expression. So it can be caused by various factors, such as invalid inputs, like some runtime errors that occur when the code is running, or even in some cases, unexpected conditions. Yeah, your program is interacting with the memory, and if things are not carried out properly, your code might be syntactically correct, but the memory can even throw issues that may cause exceptions. So when an exception occurs, so when an interruption or disruption occurs, Python tries to draw your attention to the fact that this has occurred. It even goes ahead to give you what we call an exception object, or for now, let's take it like it shows an exception, which usually contains information about the type of error and sometimes details on it, like maybe a string division is not allowed or something like that. So after it tells you that this exception has occurred, it tries to tell you that, oh, okay, maybe this is why it is occurring and that one. Okay, so we take a look at some few errors that we may have with our code and see how we can use exceptions to solve that. Okay, back to Python. So let's just say that I want to print hello world. And I intentionally forget the closing quote. Let me run my code and you see. You see now I have an error here called syntax error. And when the syntax error was raised, Python tries to tell me that this is what caused it. So it says unexpected EOF while passing. So the EOF, I don't really know. I don't know what that one means. Maybe the E may be for end or something like that, but I don't know what it means. I will not tell you something I'm not so sure of. So at least we know for this one that I have to just add the closing quote and everything will work for me. Fine, let's take a look at another thing also. Let's just say that I want to perform some division. So I would say result here equal to maybe 10 divided by 0, which is something that will throw an exception. So if I try to print result now, I get an exception, which is the first one we saw was the syntax error exception. You can see so. And this is the one for 0 division error. So it tries to describe the error as much as it can. And so 0 division error, and it tells us that division by 0. And so that is how we know that what is wrong. In most recent versions, you see that Python even tries to tell you the line where the error is occurring. And that is something very cool. And usually to show you the particular code, the part of the code that is showing that error. So now we know that it's on line 4, and on this particular logic, which is result equal to 10 divided by 0. Usually in any intelligent editor, if you click on this link that they will provide here, you see that when I put my cursor on it, it becomes a pointing hand. If you use the web almost every time, you know that if your cursor changes to this thing, then it means that when you click it, it will take you to somewhere else, another page, another section of the same page or something like that. So it took the cursor straight to, if I put the cursor at print and I click on it, it changes the cursor straight to results, telling me that this is where my error is occurring. So that is also the 0 division error or the exception we can see. So we'll be encountering some of these errors in our code. In fact, let me just type out the thing that I was explaining just a while ago. So if I say denominator, I want to be input, then maybe enter a number for the division. You and I all know that this one will return a string. Let's just assume that I forgot, so I just trusted the user, and then I decided to perform the division. Here, I'll enter my division, my denominator, sorry. Let's just pick 2. And then I get another one, which is called type error. So we have been seeing these errors. I think one of those days when we were dealing with the continuous statements, things were not working out. I think most of these errors were being thrown. So yes, if you get errors in your code, these ones look very, very simple. This error is very, very simple. But as we go ahead and explore further libraries, as we explore libraries, you get to see that one error will occur. It will call another error, another one, another one, another one. It will be a long chain of that. And when we get to those places, I'll show you. But for these cases, when you are just running our file, not depending on any other library import, we know that the error is fairly simple. In any case, when you get an error in programming, not just Python specific, but programming in general, at least for Python, let me be confident and speak that way rather. Look at the last line. That is the most important line, at least for the analysis of the error. So that one will tell you what exactly happened. And then we find out it's a type error. And usually to try to describe the error to you, like I've said, so in this case, it's an unsupported operand for types. That means the division operand, which is used to perform the operation, is not supported for int and string. And even Python will try to warn us beforehand, but just for the demonstration purposes, I intentionally run the code. So here you see that I have to now do typecasting to convert this to an integer or a float, any numeric type. So maybe float. And then now when we run our code, let me enter 2. And then now we see that the output is as we are expecting it. So that is also another error that you will encounter. There are a lot of them. I can't go through all of them. In fact, that will even be like impossible because it will take a lot of time to even run through the internet searching for all the errors or exceptions that can be raised during our Python code running. So now let's look at the error handling. Now you've seen the exceptions or the disruptions or the errors if you want. You don't want it to be so technical. Now, how do we handle these errors as they come in? Usually what will happen is that you write the file. If you have to send it to somebody, you write the file, the software, the website, whatever it is, and it will not be running on your computer anymore. It will be running on the client's computer. So if there's an error, let's say you are working for an international client, you may not really be in that position to take flight, go and fix that small line back, and then come back. And if the client is also not a programming inclined person, of course, he or she may not be. Other than that, you wouldn't have been employed. And in that case, you may not really be able to tell the client, okay, fine, open the file, go here, go here, go here. Because in most cases, you have actually compiled it into a software, it's either a website or something like that. So in the cases where we think some parts of our code can be susceptible to errors or things can go on wrong, we can handle the errors even before they occur. So I'll go ahead and even in this same example, try and then do the error handling. So I'll get rid of this for now. And then we will have the thing that we know will cause an error. Today we will introduce ourselves to 2 new, or I think 3 statements also. There's one called try. And some of the times I find myself saying that of all the things that are in programming languages, this is the, for me, this is the most important one because it really saves you from a lot of headache. So when you put anything inside a try statement, and then we now come and say except, or let me just type it here now so that I don't go ahead of myself. Now I can put this code, troublesome code, inside the try statement. And then I'll say maybe print results. So this is what I want to do. But I am afraid, or I'm being cautious. That's fine. Something may happen. So this is what I want to actually do. But because I know that an error might occur, I put it inside the try except block. We call this the try except block. The bigger green rectangle, the try except block. You know a block, you have been using it, the for loops and all the nested code statements are called blocks. So this is a try except block. So anything that is inside this try except block, even if it throws an error, your program will not crash. It will still render, but it will display some useful error message. In fact, if I should go back and show you why the program crashes, if I now come down here and do another print statement like hello, I may not see the hello printed at the terminal because my program will most definitely crash at line 5. So let me put 2 here. And you see that after it prompted me to enter the number for the division, which is 2, I did. At least if the program did successfully run, I should have seen hello also printed at my terminal at line 9. That is the last statement I wanted to print. But it did not come. You can see that our process finished with exit code 1. I told you that any number apart from 0 means our program terminated due to an error. So that means your program will crash and it may not perform all the functionalities you want it to perform. And that is why the try except block is very important. So I'll go back into that try except. I'll just say try, and this is what I want to try. And I'll go except, not exec, except. And what follows this except is if you know the particular error that might occur, you can put that particular exception there. So in this case, Python is even suggesting it. So it's a 0 division error. That one is there. I can say inside after the except or inside the except block, this is a try block where we want to perform the operation. And inside the except, you can do something meaningful like printing a useful error message to the user. Like in this case, I'll say, you cannot divide by, this is what will occur. But you also know that this exception that we are trying to catch is not what we'll actually get because I'll put 2 at the terminal. So let's see what I'm talking about. So now I put 2 and I actually got a type error and not a 0 division error. So what I can do again is to try and catch the type error. So I can put another except there. So except, and it's actually recommending it for me, but I told you that I will not be using it most of the times. Then I can also print, what should we do for the type? Maybe what you entered it's not a number. So I'm not expecting the same error at the terminal again. The program will fail with exit code of 0. That means that we did not encounter an error. I've told you this countless number of times. When you see 0, that means all was well. Initially, we were seeing 1. That means there was something wrong. So even though we did not get the value or the result we printed for us, but what we see now here is not some red angry text yelling at us. A very useful message that we rather told the user that what you entered is not a number. So that means we have caught the type error. We have caught, I guess so. Let's hope the spelling is right. I'm confused whether it's TH or HC, but it will be HC. Yeah, we have caught the type error. And so in this case where we prevent the type error from happening by casting this one to an integer, and I run it. Now I know that the type error will not happen because division by 2 integers will not raise a type error. So if I enter 0 intentionally, I get another exception. That was the 0 division exception that is now raised. You see, the first time Python runs from top to bottom, so I can say I intentionally wanted to skip the 0 division error to show you that even though it's running from top to bottom, what is inside this except block will only render if that exception is encountered. So in the first time when we run it, it did not encounter the zero division exception. That means we're not dividing by 0. So it didn't execute the statement that is in the zero division error except block. But when the type error now has been given, it was given at first, it skipped the zero division, rendered the type. Now that the type is safe, it will also skip the see if it will render the division error. Yeah, that's what I wanted to say. So you can try and catch all the exceptions you want in this world. In fact, you can be that maybe you are that smart, you can brainstorm all the possible exceptions that can happen with your code. If that is the case, then fine, you can do that. But there's also one important block that I want to introduce you to called the finally. You may not really use it. If you don't use it, you'll not be penalized. But this is where we the finally block will render irrespective of whatever the outcome of the code was. So if you usually, if let's say you are writing a program that interacts with files or something like that, you can put some important algorithms like closing of the file, or maybe closing a connection to a database. Maybe the try except block was to connect and read data from a particular database. But if there is an exception, you don't want to leave the database in memory. I explained all these things yesterday, that a file can be left in memory when it is not closed. And that might cause problems because another program running on your computer also uses the memory. They say parts of the memory, and there will be a place there where the file is not being used, but it is also there, so it can cause problems. So in the cases like that, when the exception occurs that you're unable to do what you intended to do, but you are working with files, some configurations that you have to reset to default and all that, you can put all of them in the finally. The finally block is executed regardless of whether an exception occurs or not. So for cleanup actions like closing files or releasing resources, you can use the finally block. And so here, I'll just print execution complete. Okay. So I'll run the code again. First with an exception, second without an exception. So let's just try the zero division error. You see that I got the exception zero division error. It's rendered, and I also have execution complete. Okay, so the finally block was rendered. Now let me run the code again without any of the exceptions. So I'll put 2 there, which should give me 5. And you see that I got my result, which is 5, and the statement execution complete. So you can use a finally statement for that particular thing. But in our case where we are not writing to any files, we are not even, you don't need to release any resources or memory or anything like that. We can just skip the finally and we will not be penalized. But as you take this one step further, working with files and other algorithms that cause other stuff. So that is where you want to use the finally to close database connections, release files and resources, and reset configurations and all that. What you have to do is, I told you that maybe you can brainstorm all the possible exceptions that will occur in your code. That is completely fine. But it is almost impossible, like humanly impossible to do that. I remember one of the days I told you of something that happened. Last year, my team and I wrote a software, and when during the development phase, the testing phase, I never encountered a particular error, or now in most properly an exception, until I was touring the classrooms, demonstrating the software and all that. I entered one classroom, I tried to import a file, I think so. And then an exception was thrown as a pop-up message. If not for error handling using try except crashed, and I wouldn't have been happy. So because there was a exception handling or error handling, like the try except here to handle the errors that will occur, the program did not crash. But if you're listening to what I'm saying carefully, you realize that that error I didn't even know about so sorry about this, all this stuff. So sorry. You know, from previous days that it has not been doing this. I don't know what exactly is happening to my system today. Okay, let's hope that this time around it will not mess up with us. Okay, we are up and running. So this is where we go to. So if we want to catch, we can catch exceptions generally. So what we did with the software is that we caught the exception generally, so that in case of whatever happens, we will still be safe. That is why I was still safe and I was not disgraced when I went around touring with it. So can say exception, and then I can say print an exception has occurred. Okay. Uh, what is I'm saying? So is that, oh, I entered 2 instead of 0, sorry. So let me run it again. Enter 0. Yeah. So you see that now it didn't tell me that a zero division error or something like that. It says an exception has occurred. So that will cause the exception generally. But usually if you do that, well, it will help, but it is also good if you know the particular exception so that you know how to tackle it. So if you want to know the exception, if you are catching exceptions generally like this one, you can see exception as, and then you introduce here a variable. Usually you see developers using E. This is a short form for error. But I can be more specific and say error. And then here I can say maybe an exception has occurred, and then add it up here so that I know the particular exception. So in this case, it will say an exception has occurred, and then it will print out that particular exception also. So run, enter 0, and then you see that it says here an exception has occurred, and it gives us the error part of the exception, which is division by 0. If I go ahead and remove this casting here, and I try to divide by the string, it will tell us also that this one, if I put a valid number there, it will still say so. So an exception has occurred, unsupported operand types for the division, which is int and string. So this is how we catch exceptions generally. And in most cases, when I'm developing software, this is what I do because I don't actually know the exception that may occur. Some of them, trust me, you never know. Even top softwares like Python or the VS Code or even the streaming software I'm using, whichever software you are using, no matter how good and how much you praise it, there are bugs that they fix. So each release that comes with its own bug fixes. That means there was a problem somewhere that they fixed, and it may be in a particular release, or you see that as the best state of the software until a developer, some user uses it and then encounters an error and then sends the developer a message that, hey, I tried doing this and this happened. And then they may ask you, okay, send us details of the error so that they know the particular exception. Usually that's what happens, so that if you send them details, they know that, okay, this is the exception that occurred. Is it the user specific platform like maybe Windows desktop, or maybe the user settings that has caused that exception, or it is from their code? Then they will try and fix that one also. So that is it about exceptions and error handling. I don't know if there's any comment or even any question that I have to address on air. I can do that. Other than that, we will close chapter on today and then anticipate for tomorrow. So as I always do, I will give 1 minute. If there is any questions, I answer it, and then we close chapter on today. Okay, I suppose there is no question. So once again, let me thank you for your time. And I still encourage you to keep on practicing. The only thing that will make you good, apart from watching these tutorials, is also to practice on your own. And be sure to submit the assignment if you have not done so. You have about 2 days to do so. Yeah. So I'll see you tomorrow. And until then, keep creating. I'll be happy if you send me some crazy stuff you've done with what you've learned so far and all that. So yes, I'll see you tomorrow, and goodbye.